SAS third year CSDS, subject name compiler design, unit 1. Now we are going to discuss about finite automata. Automata is a kind of machine which takes some string as input, and this input goes through a finite number of states and may enter in the final state. Automata is a machine that can accept the strings of a language L over an input alphabet. Automata theory is a study of abstract computing devices which are closely related to today's computer. Finite automata are used to recognize patterns. Patterns can be token, and these patterns are defined by means of regular expressions. In programming language, keywords, constants, identifiers, strings, and numbers can be considered as tokens. It takes a string of symbol as input and changes its states accordingly. When the desired symbol is found, then the transition occurs. Finite automata. At the time of transition, the automata can either move to the next state or stay in the same state. Finite automata have two states, accept state or reject state. When the input string is processed successfully and the automata reached its final state, then it will accept the state, otherwise it is called as reject state. So this is the definition of finite automata. A finite automaton is a collection of 5 tuples, that is Q, sigma, transition, Q0 and F, where Q is called a finite set of states, sigma is a finite set of the input symbol, Q0 is the initial state, F is the final state, and transition is Q into sigma, which implies Q. So this is called the transition function. So this is a transition diagram of finite automata. Finite automata having number of states. So here 3 states are available, Q0, Q1 and Q2. Q0 is a starting state, otherwise we can call it as a start. Q2 is a final state, otherwise we can call it as a accepting state. Q0 having the self loop of input value 0. Q1 have the input value of self loop 1. Q2 have the input of self loop 0 and 1. So Q0 gives the input value to Q1 as 1. Q1 have the input value gives to Q2, that is 0. So the same value is we are going to represent in the transition function and transition table. So here 5 tuples are we are going to explain. Q is equivalent to, that is set of states, Q0, Q1 and Q2. So sigma is what are the symbols you are using in the transition diagram, that is 0 and 1. Q0 is the initial state or start. F is the final state, Q2. Here we are going to represent transition function and transition table using the transition diagram. Transition of Q into sigma, which implies Q. That is, transition of Q0, 0 gives the Q0 as a self loop. Transition of Q0, 1, which gives the input to the Q1. So we are representing as Q1. Q1, 0, that is Q1, 0 gives the input value 0 to the Q2. So we are writing as Q2. Same way, transition of Q1, 1 gives a self loop. So we are writing Q1. Q2, 0, Q2, 1, both are having the self loop of input values. So both the values having Q2. In the transition table, the same transition function will be applied here also. By using the transition diagram also we can form the transition table. By using the transition function also we can form a transition table. In the present state we need to represent What are the states are available in the transition diagram? Here three states are available: Q0, Q1 and Q2. Q0 is a starting state, that is we are representing as arrow, and star represent final state or accept state. In the next state of input, 0 and 1 symbol is representing, and Q0 and 0, which gives the value Q0, that is a self loop. Q0 and 1, that is we are giving the input 1 to the Q1, so we are writing Q1 here. Q1 and 0, Q1 and 0, which gives the input to Q2, so we are writing Q2 in this position. Q1 and 1, Q1 and 1 is the self loop, so which gives the value 1, so we are writing Q1 here. And Q2 having the 0 and 1 as a self loop, these two values as the input to the same Q2, so we are writing Q2 in the same 0 and 1. So types of finite automata. There are two types of finite automata, DFA and NFA. So DFA is a deterministic finite automata, NFA is a non-deterministic finite automata. Deterministic finite automata. Deterministic refers to the uniqueness of the computation. The finite automata are called deterministic finite automata if the machine is read an input string one symbol at a time. In DFA, there is only one path of specific input from the current state to the next state. DFA does not accept the null move, that is, DFA cannot change state without any input character. DFA can contain multiple final states. It is used in lexical analysis in compiler. Deterministic finite automata. By using the transition diagram, we are formed the transition table. In the present state, Q0 and Q1 is available. Q0 is the start and Q1 is the accepting state. We are having two symbols, 0 and 1. Q0 have the value 0 gives the input value to Q1, so we are writing Q1. Q0 comma 1. Q0 comma 1 is a self loop, it gives the input value 1 to Q0, so we are writing Q0 here. And Q0 comma 0, Q0 have the self loop, so we are writing Q1 here. Q1 gives the value 1 to Q0, so we are writing Q1 comma 1 to Q0 here. Non-deterministic finite automata. It is used to transmit any number of states for a particular input. It can accept the null move. It is easy to construct an NFA than DFA for a given regular language. The finite automata are called NFA when there exist many paths of specific input from the current state to the next state. Every NFA is not DFA, but each NFA can be translated into DFA. NFA is defined in the same way as DFA, but with the following two exceptions. It contains multiple next states and it contains null transition, that is epsilon transition. By using the non-deterministic finite automata transition diagram, we are going to form the transition table. In the transition table, we are representing the present state, three present states, Q0, Q1 and Q2. Q1 gives the arrow, so it indicates the start. Star indicates accepting state. 0 and 1 as a symbol. Q0, which gives the input value 0, self loop, and it gives the input value to Q1 also. So we are representing Q0 and Q1 in this table, and Q0 have the 1 as the input to Q1, so we are writing Q1 in this table. And Q1 gives the input value 0 to Q2, and Q1 gives the input value 1 to Q0. So we are writing Q0 in this table. Q2, next Q2 have gives the input value 0 to self loop of 0 as well as 1. So we need to represent Q2 in both the places 0 as well as 1, and Q2 gives the input value 1 to Q1 also. So we need to write Q2 comma 1 in the place Q1 comma Q2. In the 0 position, Q2 alone we need to write.